Let's start working on our inventory library. Now, unlike many of the libraries, I didn't start it with J and I because inventory has the I itself. So either call it JInventory or JInventory, whatever you want. I will call it JInventory. The very first thing that we want is a single class that is called recipe simple inventory. As the name suggests, it's extending this simple inventory and it implements the recipe input. Now, if I add the recipe input, you see that it says that add the get stack in a slot. Before this, I can make something else and I will call it base simple inventory. Now, this one extends the simple inventory and that's it. The recipe will extend my base simple inventory and implement. I will work with a hierarchy of classes that are not abstract anymore, but one complements the other one. This will give you flexibility about what you can have inside your own mod as you need, or in your own API as you need. Now, here's a question. What is an inventory? If we take a look at simple inventory, you see that an inventory is boiled down to this, a list of item stacks. And everything else on top is methods to handle this, a list of item stacks. When you are coding in C# and Unity 3D, this is exactly how you would write an inventory. You would make a list of items and that would be it. However, here you see that we have a list of inventory change listeners as the events. So we can call those events and we can add the listener, remove the listener, get the stack, clear the list, remove the stack, and that list manipulation stuff. And finally, we have a size. This is the size of your list and nothing beyond that. So whatever we are working on, keep in mind that on the back of your head, when you read the inventory, think about a list of items, nothing complex. So we want a constructor that accepts a size. It calls the super with the size. And again, we have a constructor that accepts an item stack array. And again, it calls the super. Now you may say, what else? And I will answer nothing. Now, here's the thing. It's exactly the same simple inventory. Why did I add it? Why did I add this layer of abstraction? Because I don't know. Maybe at some point in future, I make the decision that, you know what, I want to override a method from simple inventory for whatever reason. This layer of abstraction will give me the flexibility of having that functionality. Now here I implement the method and you see that I'm not gonna add any constructors because the constructors are the same. All I'm doing here is that I'm saying get stack from the slot number. And I prefer to have it as index, slot index, because when I'm talking about a slot a few minutes later, you will see that I'm talking about the real slot class and not an integer. And again, this is our recipe simple inventory, nothing complex. Now the next one is called sync simple inventory. Now synced or syncing, I'm not sure. Turtywort is using syncing and it means that each tick it's syncing itself. I use the synced because I think it makes the same concept in my memory. So inventory, synced simple inventory. Now synced simple inventory extends the recipe simple inventory, but implements an interface that is syncable storage. Now syncable storage is not here yet and we want to add it. Wait a minute, this is iSync. I already implemented that. So why don't I see the iSync? Because if I go into the Gradle.properties first, I need to update these. The G reference would be 2.0.0.5. I don't use the logger Jiralib, yes, 2.0.0.5. And inside build.gradle, I have to open the Jiralib. Now, I'm not sure. I think I used the reference for the ID. However, I'm not sure. We'll see. Right now, I need to reload the Gradle project so that I get the latest version of our API. I went ahead and loaded all 4 of them because I think all 4 of them will use Jiralib and I want to make sure that they are okay. However, my focus is on JInventory right now. So I will wait until it's finished. Okay, now that I imported the iSync, it should yell at me about implementing methods for the sync and get syncables. Now, here's the thing. I don't want to return a list of iSync because at the end I will say this. No. But if you want to, you can do that. Or any class that is actually overriding it may want to overwrite this, but our focus will be the same. Before that, we say private final. This is updatable BE and we call it block entity. The next one is a private boolean, and we call it is dirty equals to false. Whenever you will work with the syncing, you need that is dirty. Now, for the constructor, we will ask for the block entity and int size. Now, we will assign the block entity, we call the super with the size here, because this should work. If it's not working, take a look. It says create constructor that asks for the size, so it should do the super with the size. Again, another constructor for the item stack. That's it. Basically, I had to add it here. I was hoping that if I would do this here on the base, it wouldn't need this one. Okay, so now that we have the size, we want another constructor that asks for the updatable BE and item stack and calls the super on items and then assigns the block entity. The sync method is what we are focusing on right now. We say if this dot is dirty and this dot block entity does not equal to null, and this dot block entity that has word and not this dot block entity dot get word dot is client. So basically we want to make sure that we are on the server side and we have a word that is being instantiated. Then we say this dot is dirty equals to false. That's the very first thing we do. And then we say this dot block entity dot update, because we already sure that it's updatable. Now there is one more method that I want to implement, and that is mark dirty. Whenever we mark the entity as the dirty, we want to say this dot is dirty equals to true, so that the syncing and updating will happen. Finally, we want to get the block entity, and I will do it at the end. Public updatable BE, and we say get block entity. This will return the block entity we cached. Now I think here we will return this as the get syncables. Why not? And that's our syncing. Now the next one is an extension of the synced, basically. So we will have a class called predicate simple inventory. And you see that I have warning here. If I come back here on this warning, it says that replace with object require non-null. I think I will suppress that. So I don't know, I will suppress that error later. Here we want to extend this from the synced one. And again, we have to implement the constructors. We will go with both of them. So here we want a predicate. Okay, so private final a by predicate of item stack and integer, and we call it predicate. The idea here is that we will be able to test any amount of item stack compared to this inventory using that predicate. At the end, when we are calling the size, we say by predicate of item stack comma integer, and we call it predicate. Here, after calling the super, we say this dot predicate equals to predicate, and the same thing will happen here. So after the block entity, before this dot item stack, we ask the predicate, and here we say this dot predicate equals to predicate. Then we want to override a method, and that is valid. Instead of calling the super, we return this dot predicate dot test the stack with the what is the integer slot index, we should say, with the slot index, Then we will have a method to retrieve that predicate. So public by predicate of item stack and integer, we call get predicate. All it is doing is returning this dot predicate. Now here's the thing, Turtivorti had this interesting method call for creating empty fluid predicates and empty slurry predicates. These are related to his mod, especially the slurry one. I'm not sure if I will add it or not. Honestly, slurry is something that is not related to inventories, and also fluid is not related to inventories. So I will have my own predicate fluid storages. I think all he's doing is saying that, hey, a storage of fluid variant container item context with constant stack find fluid storage item. Now stack here, let's copy it, because I'm not sure if this should be it's an item stack. Interesting. Find fluid storage item. Oh, okay. Now this is interesting. Well, I will hold on to this. I will not add it yet. I will keep that in mind, and I will mark here with a to-do. Check if we need the fluid and slurry code, because I think I can handle it inside their own libraries. Okay. And yes, the predicate and the synced are coming from Turtivorti. So again, let's credit him where we should credit. There we go. So the synced is his idea. The recipe is actually his idea, although it's not something big. colleague, but I will credit him. And the base is just, a basic class. So why there is nothing special about that one. Okay, now that we have these, we have more inventory types. One is the output simple inventory. Again, these are coming from his repository, so I will just do that. It extends the predicate simple inventory, so it goes above the previous one for the both of them. And here we are not asking for a predicate, interestingly enough, because we are gonna make the predicate ourselves. So for the predicate here, we use a slot and the stack to go into a lambda, and that is false. Means that we are not gonna accept any item inside this slot or in this inventory. Okay, so I will copy this and put it here. The output inventory is all about accepting the result of crafting recipes in machines, so the user should not be able to add anything, and this is why we are hard coding that predicate, making sure that it will behave itself. So the next one is the starting of the inventories, and honestly this is the very first one that we will seriously work on and we will expand upon it, and this is predicate inventory storage. Now I will change some of these names in future, but this is a record, it's not a class, and I will add a package for itself, so it's a record package. I'll move it there, and this record will use the inventory storage, and we call it storage. It asks for a supplier of a boolean, and we call it can insert. It asks for a supplier of a boolean, we call it can extract. And finally, let's close the Gradle. It implements inventory storage, and finally we need to implement the get slot, insert, extract, and iterator. Now inventory storage, as you recall, is an interface. This interface is responsible of the implementation of storage of item variant and responsible of handling them. Let's start with the cache on top, because inventories are something that we work with them a lot. So a private static final concurrent map of inventory storage and a concurrent map of predicate key that we don't have, and predicate inventory storage, we call it cache, equals to new map maker dot weak keys dot map make map. Now the predicate key is a class that we will add ourselves, so I will do it in future right after this record class. I don't want to jump back and forth between things. I will just add it here, no class, and it's predicate key. So keep that in mind. We come back, it's getting imported so that we get rid of that error. After the cache, we want a method, and that is public static that returns a predicate inventory storage, we call it of, and here we ask for inventory storage, a supplier of boolean can insert, a supplier of another boolean. Basically I could copy paste it, can extract, and this will make the concurrent map of predicate key, comma, the predicate storage. Actually, yeah, we call it inventory cache equals to cache dot compute if absent the inventory storage, called it storage, and we give a lambda of new map maker dot make map. After that, we say the predicate key, we call it key equals to new predicate key. Of course, we don't have the constructor, but we will say can insert and can extract. After that, we return the inventory cache dot compute if absent of the key, comma, a lambda that says new predicate inventory storage with the can insert and can extract. Now remember, this is a more complex mapping compared to your normal hash maps. Now get slots, we want the return of delegate dot get slots. Now delegate here is actually the storage, so I will rename that to storage dot get slots. Let's go with this dot storage dot get slots. There we go. That was a comma, a typo. Okay, now insert will happen later. I want to have few more overrides, and that is support insertion. We return the this dot storage dot support insertion and can insert dot get, and let's use this here again, although it should be redundant. Then we have support extraction. We go with this dot storage dot supports extraction and this dot can extract dot get. Now we want the insert method that is not there anymore, interestingly enough. Okay, public long insert that accepts an item variant, we call it resource, a long max amount, and a transaction context we call transaction. We return the storage dot insert, the resource, the max amount, and the transaction context. Okay, what's the problem here? It's already defined, so it is an overload. Why didn't you show the overload? I think it says the max amount is different. Okay, let's see. Oh, here we go. Okay, that's the insert. For the extract, let's make it context as the name. For the extract, we will say the storage dot extract the resource. Actually, let's see. Resource max amount transaction context. That's it. Then for the iterator, we want the storage dot iterator to be returned. And it says that as not null. You should annotate it as not null. Let's do it. Then we have more methods, get slot count, and here we want to return the storage dot get slot count. We have the get slot with slot index. We return the storage dot get slot with the slot index. We have the equals method that accepts an object. All we do is return storage dot equals the object. Again, this one says should check the class of its parameter. Oh well. We have the hash code that returns storage dot hash code. We have the toString that returns predicate, inventory, storage, and inside brackets %s dot formatted with storage dot toString. Then we have non-empty iterator first. This one is storage dot non-empty iterators, and we have non-empty views. Guess what? It's storage dot non-empty views. Get version, we want the storage dot get version, and that's it. As you see, it looks like it's a wrapper around the normal inventory storage. However, here we are caching it based on the predicates. We handle every method based on those wrapping around. Now the final one is predicate key here so that the whole thing works. We have a private static final supplier of boolean can insert. We duplicate it, and that is can extract. Then we have a constructor that accepts for the supplier of boolean. It's called can insert, and then a supplier of a boolean called can extract. Then we say this dot can insert equals to can insert. This dot can extract equals to can extract. After this, we want to override the equals method, and here we say if this equals to the object, we return true. Otherwise, if object equals to null or get class does not equals to object dot get class, we return false. Then we have the predicate key, we call it that, equals to typecast to predicate key the object. This is a blind typecast, okay? The thing is that on top we made sure that the classes are the same. Then we return the objects dot equals can insert, and the other one that dot can insert, and objects dot equal, actually I'm not sure why it has s. It gives me an error and it says that non-static method cannot be referenced from a static. I think it's equal now, and we say can extract with the other one dot can extract, and these two are saying that qualify statics. Now did I make them static here? That was wrong. They don't need to be static. And finally we have the hash code that returns objects dot hash code with can insert and can extract, and that's basically our class. So we are just accepting two suppliers of booleans and give the comparison and the hash code for this class. It's nothing complex, but it will solve the whole problem here, and that is predicate inventory storage. Now we have two more classes to cover, and this is getting a long video, so I will cover them inside another video all by itself.
If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun everyone. Bye.